Hello and welcome to Chemistry Nuggets, where you can polish your knowledge and clear your doubts. So friends, today's video is about redox reaction, that is oxidation and reduction reaction. So let's start the video, but before starting, if you haven't subscribed the channel, subscribe it and press the bell icon so that you can get the notification for the next coming videos. So friend, redox reaction, as the name Re stands here for reduction and ox stand for oxidation. So collectively it is called redox reaction. This is the short form of oxidation reduction reaction. So let's have a look on the reaction first. What is going on here? Here copper is added to oxygen and it will give copper oxide. What is going on here? Copper is changing to the copper oxide, that is addition of oxygen. We can say copper adds oxygen, addition of oxygen. This is called oxidation. Fine. Let's come to the second example. Here copper oxide is added. When added to hydrogen, it gives copper and water. So see carefully what is going on here again. Here copper oxide gives the copper. It means copper oxide is losing the oxygen here. Now what does this mean? If any substance loses the oxygen, the reaction is known as reduction. So this is one kind of definition which one can give for oxidation and reduction reactions. So let's talk about all the possible definitions which one can give. For oxidation, if there is a gain of oxygen or loss of hydrogen or loss of electrons or gain in oxidation number, if any one of this is happening, we can say that reaction is oxidation reaction. In the same way, if there is a loss of oxygen, if there is a gain of hydrogen, if there is a gain of electrons, or if there is a loss in oxidation number, then one can say the reaction is reduction reaction. This much clear? Now let's come to some examples to learn how we can understand. Here in the first example, zinc oxide plus carbon, it gives zinc plus carbon monoxide. So what is going on here? From zinc oxide to zinc, it means reduction of oxygen, loss of oxygen. Loss of oxygen is our reduction. It means zinc oxide is reduced. We can say this process is reduction, and we can say zinc oxide is reduced to zinc. Now come up to carbon. Carbon in turn change to carbon monoxide, means there is addition of oxygen or gain of oxygen. So we can say this particular part is doing oxidation. And now we can say carbon is being oxidized to carbon monoxide. Understand? From this reaction only we can understand that oxidation and reduction occur simultaneously. There is a note that oxidation and reduction occurs simultaneously. Always they occurs together. Okay, if there is something oxidizing, in the same reaction something is reducing. And one more point, in this reaction we can say zinc oxide is reducing. Fine. Who is the agent which starts this reducing reaction? Is the carbon. So here carbon is a reducing agent. Here carbon is reducing agent because it initiates the reduction process. In the same way, carbon to carbon monoxide is the oxidation process, and which substance is initiating this oxidation is zinc oxide. So we can say zinc oxide is a oxidizing agent. Same thing we say here in the column, we can say when there is oxidation, if any substance is oxidized, that means that substance is a reducing agent. In this reaction, carbon is oxidized, so carbon is reducing agent. In the same way, the substance which is reduced is a oxidizing agent. So here we can say zinc oxide is reducing, so zinc oxide is oxidizing agent. This much clear? Let's have one more example. Here we can see hydrogen sulfide plus chlorine gives sulfur and HCl. Here we can see there is no oxygen. Then how could one can give the oxidation reduction reaction? Here we can see hydrogen is there, so we will work on hydrogen. Here hydrogen sulfide turns to the sulfur. So what is going on here? Loss of hydrogen. We can see here clearly loss of hydrogen means oxidation. So here which process is going on? Oxidation. Now in the second part, chlorine gives hydrogen chloride. It means chlorine adds hydrogen, that is gain of hydrogen. So this part is our reduction. This much is clear. Now we can tell which is oxidizing agent and which is reducing agent. So the substance which is oxidized is reducing agent. Here H2S is oxidizing, that is H2S is our reducing agent, and chlorine is reduced. So chlorine is our oxidizing agent. As it is also given in the box, the one which is oxidized, the oxidation is going on, that is reducing agent. So here H2S is oxidizing to H2S is a reducing agent. In the other reduction part, the substance which is reduced, that is chlorine is reduced here, that is oxidizing agent. Let's have one more example to sharpen the knowledge. Here MnO2 plus 4HCl, it gives MnCl2 plus 2H2O plus Cl2. Now first work on MnO2. It gives MnCl2. Now we can say MnO2 is losing the oxygen. Losing the oxygen means reduction. So this process is going under reduction. Now work on the HCl. HCl is turning into H2O, means addition of oxygen. So we can say this process is gain of oxygen is oxidation. This much clear? Then we can say the thing which is reducing, that is MnO2, is our oxidizing agent. and HCl is oxidized. Here in this reaction, HCl is oxidized to H2O. So it is a reducing agent. So friends, from this whole story, let's summarize. Now we can have some facts about oxidation reduction reaction or redox reaction. That is, first thing, that oxidation and reduction always occurs together. Always. That means if there is oxidation is happening, definitely there is reduction also going on there. In the same reaction, oxidation and reduction both will occur. The one more point that is to be noted is the substance which is oxidized is a reducing agent. So, oxidized substance is our reducing agent. In the same way, reduced substance is our oxidizing agent. So if the oxidation reduction is going on, if one substance is oxidizing, so who is the main culprit for the oxidation of that? Is the other element who itself is reducing. So if I am going to oxidize something, I need to be reduced myself. This is going on here, that's why it is a simultaneous process. That's all for today, oxidation reduction reaction. Hope you guys like the video. Please press the like button before leaving the video. Thank you.